The project basically is a research project to develop a new technology and technique to characterize the soil movement beneath pavement structures.
The problem is that in Texas, in particular, in the central US and in Texas, we do have what we call expansive clays. The clay will swell when it gets wet and will shrink when it dries out. And that is very damaging for pavements. This is what you would typically see in a pavement that is over expansive clays.
The soil movement beneath our pavement structures can become very detrimental if those movements are very large. And so the better we engineer those foundational layers, the better long-term performance we get and the less maintenance dollars we have to spend on rehabilitating our pavement.
What our project did is it found a way to characterize the swelling, but instead of measuring an index property, by measuring the swelling. So these are the samples in which we use to get the data, and we're going to let water through a soil sample in order to get it accelerated. So what is going to happen is, under acceleration, it's going to swell. And what the centrifuge does is makes this happen quickly. And so essentially, at the end of the project, we would have created the methodology to use this data and the equipment that can potentially be used in multiple labs across the state so that this can be done in-house expeditiously. And honestly, this makes a difference in million-dollar decisions that need to be made based on this data.
Traditional methods from the 1950s and 60s in laboratories, 3D swell tests, they are fairly accurate, but they're very laborious and take lots of time. And so the best way to ever characterize soil movement is by measuring it directly. And so we believe that with centrifuge technology, it gives us the ability to get those characteristics within hours, where the traditional test took weeks. It also is actually characterizing what actually happens in the field a lot better than what we measure in the laboratory.